Hi everyone, my name is Dr. Vanessa Moreno, and in today's video we're diving into resistance training, adaptations, critical variables, and programming. Full disclosure, I'm also a mom of two, so if you hear a bit of background commentary, it's likely from my tiny co-hosts. Let's dive in. Resistance training is a modality of exercise that is well known for its role in improving performance by increasing muscular strength, power, and speed, hypertrophy, muscular endurance, motor performance, balance, coordination, as well as body composition. We have to discuss the acute versus chronic results. Acute meaning short term, chronic meaning long term. So this is going to be directly related to the design of the program. So it's critical to dictate what acute exercise responses are a part of that program. So it's a resistance training program includes several variables interacting with one another to provide a stimulus for a specific adaptation. So we have these 7 critical variables. We discussed a few of them last section: choice of exercise, order of exercise, frequency, how often are you working out, how often are you utilizing specific location of the body, upper body, lower body, muscle groups, intensity, how heavy or the load that you're lifting. This can also be interpreted as effort. Volume, referring to your sets and your reps. Rest, how much rest is in between each set. So that's the difference between frequency and rest. Frequency is the number of workout sessions. Rest is the time between sets within a given workout. And then lastly, we have progression. How are you progressing? Because the ultimate goal for any program should be to continuously progress, even if they are small indicators or small results. The training program for athletes demonstrate guidelines based off of the ACSM, the American Sports Medicine, as well as National Strength and Conditioning Association, NSCA, provide guidelines for us to determine the best way to effectively design a program for our athletes. So again, that goes back to evaluating, assessing progress for the progressive chronic increase in performance over time. We mentioned the 7 critical variables: choice, order, frequency, intensity, volume, rest, and progression. But what is the purpose of these? So the critical variables are essentially your tools within your toolbox to design an effective program. So we need to determine the needs of the individual for that program, which we've done previously in section 1, the needs analysis. The strength and conditioning expert will then use these tools, referred as the acute critical variables, utilize the information provided from the needs analysis to determine and create a program that will meet the specific needs of the athlete for optimal progression over time and prevent training plateaus. We are wanting to avoid plateaus because these are essentially dead spaces in programming when we do not further our improvement. When this takes place, we need to manipulate the program variables in order for further progression. Adaptation and benefits to resistance training. In order to design an optimal resistance training program, it's key to have an understanding of the human body's acute physiological response to training and subsequent adaptations to take place. For example, the information you've learned from A&P biology, kinesiology, exercise physiology, all are critical to understand the adaptations that lead to performance enhancement. Resistance training elicits a number of benefits to not just one system within our body, but multiple. We have improvements to the nervous system, muscular and connective tissue, the cardiorespiratory system, and endocrine system. We're going to increase in muscle size, our strength, power, and endurance. Muscular adaptation entails an increase in size, which means we have an increase in strength. We can have an increase in enzyme activity, which leads to a speeding of this increase of speed of ATP turnover, meaning if we can break down ATP at a faster rate, we can utilize that energy quicker for activity. Fiber transition. Within the muscle, we have different types of fiber, from type 2X to type 2A. We discussed 3 subcategories, type 1, 2A, 2X, but know that we're on a continuum. It's not simply 3 types. It's this white to black all the way through grayscale, which leads to architectural changes. Enhanced oxidative capacity. So our cardiorespiratory system allows for an increase in capillary and mitochondrial density, and are characteristics of resistance training programs with strong aerobic components. So our connective tissue is really important because as our muscle increases, we also need our connective tissue to hypertrophy and have structural changes as well to support the increase in strength and hypertrophy of the muscle. Our endocrine system is of great significance during an acute bout of resistance exercise, but also critical for post-exercise and tissue remodeling process. We know that the cardiorespiratory changes occur mostly as a result of the heart's capacity to tolerate the stress that we're placing on it, meaning how much are we placing stress on the heart to pump out blood efficiently and effectively. Changes to the cardiorespiratory system as a result of resistance training is a stimulus for increase of the heart musculature. We have a change in structure as well as size and contractility. Collectively, these all work together to enhance performance. The last bullet point, neural defense mechanisms become desensitized. In exercise physiology, we discuss muscle spindles and GTOs. These are our reflexes. They're there for a protective mechanism to prevent injury, but over time, they may become slightly desensitized, which allow us for potentially higher training levels. So again, put all of these together. They are highly dependent on a resistance training program used, but they have the ability to adapt and enhance sport performance based on the magnitude of progressive overload, variation, and specificity of those training variables. The tables provided are physiological adaptations to resistance training, specifically discussing the systems from the previous 2 slides, the neural, the skeletal muscle, the cardiorespiratory, connective tissue, as well as our endocrine, which is our hormones. Customizing resistance training programs. The most effective resistance training program meets the individual needs or goals that result from the performing a needs analysis, as well as ensuring that the design is goal-oriented. When all relevant information is gathered and the athlete is deemed healthy enough to perform resistance training, the process of program design is initiated. So we have a lot of these questions that are provided. Many of them overlap from our needs analysis. For instance, are there health concerns or injuries that we need to be aware of? What type of equipment is available? What is targeted frequently? Muscle groups, energy systems, muscle actions. If training for sport or activity, what is the most common site of injury? What is the goal? So these questions continuously come up and are discussed for continued performance and progression over the long term. Resistance training variables are 7: choice, order, frequency, intensity, volume, rest, and progression. So choice of order or choice of exercise is to also include not just the exercise itself, but how to complete the exercise. For instance, the velocity of the movement. Is it fast or is it slow and controlled? Altering one or several of these variables affect the training stimuli and ultimately the adaptation for the individual. Therefore, proper prescription involves manipulation of each variable to the specificity of the targeted goals. For instance, if we wanted to improve power output for a football athlete and programmed them to run 5 to 7 miles, would this make sense? No. The adaptation from the 5 to 7 miles would result in reduced strength, reduced power, but increased aerobic components, which is the opposite goal for our football athletes. So again, how you manipulate these variables are critical and must be specific to the targeted goals of the needs analysis of the sport and athlete. Exercise selection. The exercise selected during training plays a critical role. For a biomechanical perspective, exercises can be defined by the type of muscle contraction, type of joint movement, and whether they involve the open or closed kinetic chain, all in which we discussed in the previous section for our needs analysis. Further, all major muscle groups should be trained and prevented to prevent any muscle imbalances. For instance, if you were to program a bench press, which is in the anterior, which is the front, we should also include a posterior exercise for any imbalances and avoid any of those imbalances. So we would then do something for the back. You do the chest and the back, as well as minimize any risk of injury. So further considerations: the type of contraction. Physiologically, our eccentric, ECC, provide greater force per unit of muscle cross-sectional area. Therefore, less muscle activation is required and less ATP is required in comparison to a concentric muscle action. The concentric muscle action is known as that sticking point. That's the weakest point of the exercise range of motion. Think of a squat. As you squat down and then proceed to stand back up, if there's a point at which you're trying to stand up and no longer can because of the resistance, because of the load, this is known as your sticking point. This is the weakest point in the exercise range of motion. And lastly, you have the isometric. stabilizer muscles in between eccentric and concentric, gripping weight, and strong activation of the trunk musculature, for instance, a plank. Joint involvement, single versus multiple joint. You may have both of these included in your program, but always remember which we'll talk about in a couple of slides, the order. Multiple joints, because they require more energy, more ATP, more balance, should always be done at the beginning of the workout. Single should be later. Unilateral and bilateral. What if someone is injured? Can they still train? So unilateral is simply a single leg or single arm, where bilateral means two, where we're standing on two legs or using both arms at the same time. If someone's injured, can they still train? Sure, if they have been cleared to do so. We can still train one side of the body and still have some results of improvements to the other side. We have this neural effect, bilateral deficit, where we're able to actually produce force on one side and still have some improvements take place to the other side. So if someone's injured, they shouldn't just stop working out unless the doctor has advised them to do nothing. And then lastly, the type of equipment, machines versus free weights. There's a big difference between the two, and the reason why you see a lot of weight rooms for professional sports, college, collegiate, as well as high school, don't have a lot of machines. There's an actual reason for that. So let's go to the next slide to discuss. Here are your list of reasons or variables that affect free weights versus machines. Let's start with machines. They're easier to balance for novice lifters. So it's easier because they provide the line of resistance. Variable resistance throughout the range of motion. However, they are less sport specific. So you cannot mimic movements because they provide that line of resistance. So it's easier to change weight and you don't need a spotter. So the big thing here is that, remember, we need to mimic movement, not muscle. We don't need to train muscle. The goal is to train movements that are mimicked on the field, on the court. So machines do not do this effectively. Now you can do bits and pieces of it, but it's not necessarily the whole picture. In comparison to free weights, it requires a whole lot more balance. Vertical resistance. We have a constant resistance throughout the range of motion. It's very sport specific. It accommodates all users of all sizes. For instance, on a machine, for someone who is very short or very tall, may not fit appropriately within the chair or in a specific machine because of their size or even weight. With free weights, it's more difficult to change or add weight because of the balance and because of that vertical resistance. So it is more challenging. Free weights do likely require a spotter dependent on the type of movement that you are completing. For instance, if you are doing an exercise that is over the face, over the head, on the back, or on the shoulders, these require a spotter. However, if you are completing a power exercise, such as a power clean, a snatch, or a jerk, stay as far away from the lifter as possible, as these can hurt you as the spotter, also the lifter if someone gets in the way of your lift. Exercise order. There are 3 basic structures. Of course, there are others, but here are some basic ones. 1, total body, when you work out the entire body in one workout session. The most common is what's known as the upper-lower split, where you have an upper body push, lower body pull day, And then on the next day, you'll have the opposite, which is an upper body pull, lower body push. Now, this is one of the most commonly used programs for athletes, powerlifters, as well as bodybuilders, dependent on the number of training sessions you have per week. And then you have the muscle group split routine, where you're focusing on individual muscle groups, which again is not the best way for athletes. So the importance of exercise order. It significantly affects acute lifting performance and subsequent changes in strength. So the primary training goal should dictate that order. Again, exercises performed earlier in the workout are completed with less fatigue because you are not as tired yet. Therefore, you are yielding the greatest amount of force. You're able to lift more weight or have a greater load. Studies show that performance of multi-joint exercises, such as a bench press, squat, shoulder press, declines significantly. So your performance for those movements will decline significantly if you do it later in a workout following exercises that have similar stress as a result of fatigue, which makes sense. So we want to make sure when we are programming, we provide that program in a specific order. Perform power training first, then large muscle groups before small muscle groups, multi-joint before single joint, and assistive exercises last. Some quick guidelines for exercise orders you can review. This is an example table of resistance training frequency recommendations based on a competition season. This is reflecting the number of training sessions in the weight room. So if someone is off season, they can train more frequently. If they're in season, it's going to be much less because they'll have games, because they'll have practices with their teams. So it really depends on the activity level of that athlete. Intensity. This is your king of all variables. If you screw up the remainder of your critical variables in program design and only get this one variable right, you may still get some adaptation out of it. So intensity is simply meaning load, the amount of weight lifted or resistance with which one exercises. So it's highly dependent upon other acute program variables such as exercise order, muscle action, and rest interval length. So the inverse relationship, as volume goes up, intensity must go down, and vice versa. So intensity, if intensity increases, if you're lifting a higher load, near your maximal ability to lift a weight, the number of repetitions will decrease. So intensity and volume are inversely related. Great test question. So it's typically prescribed as a percent of the athlete's one repetition max. For instance, if someone can lift a squat or lift 100 pounds one time for a squat, 80% of their 1RM would be 80 pounds. As we get closer to that 100 pound mark, the number of reps, volume, will decrease. So how do we increase our intensity? There's 3 different ways. We can increase our relative percentage of 1RM, meaning that 80% will continuously increase over time because that 100 pounds will slowly improve. 2, training with a rep max. And 3, increasing absolute load, so simply adding more weight. The combination of these 3 will allow us to have improvements over time and increase our ability to improve overall strength. Ultimately, which method that we use, we should use a combination of all 3. Training load is the summation of total number of sets and repetitions performed during a workout. So training volume can be manipulated by changing the number of exercises performed per session, the number of repetitions per set, and the number of sets per exercise. Again, an inverse relationship exists between the number of sets and the number of exercises performed in a workout, as well as the volume and intensity. That is, volume should be reduced if significant increases in intensity are prescribed. High intensity, meaning closer to that 100 pound mark, the lower the volume we will have. So we can find our total volume load by multiplying weights. We can find our total volume load by multiplying sets and reps and the weight together. Training volume can be manipulated by the exercise performed, the number of sets, as well as repetitions. It's also shown to increase metabolic and hormonal responses associated with high training volume. So specifically, when we talk about our training goals, we have 4 of them. We haven't mentioned them yet, but we will be mentioning them in the next slide. Hypertrophy is a goal where you have a higher volume, which would increase hormonal responses for increase in muscle size. So total volume depends on the goal of training. Here are 4: power, strength, hypertrophy, and muscular endurance. So in total, for a training session, we should have roughly 2 to 6 sets per exercise or superset of exercises. In total, we should have roughly 10 to 15 sets throughout your entire workout, which would roughly be about an hour, give or take. So how many repetitions should we complete for a specific goal? For power and strength, we have a 1 to 6 repetitions. We go from 6 to roughly about 12 for hypertrophy if the goal was to increase in muscle size. And if your goal is muscular endurance, now this chart says 15 to 25, but a good rule of thumb is roughly 12 to 15. Rest intervals. As mentioned before, rest intervals is simply the rest in between each set. So rest interval lengths depend on training intensity, again the goals, fitness level, and use of targeted energy systems. The amount of rest between our sets and exercise significantly affect the metabolic, hormonal, and cardiorespiratory responses to an acute bout during a resistance exercise, as well as performance of subsequent sets and training adaptations. So responses to short rest intervals, we have an elevated heart rate. If you don't fully recover, your heart isn't at resting levels, therefore you have an elevated heart rate. Your subjective rate of perceived exertion may increase. This is referred to as the 0 to 10 scale or the 6 to 20 scale. Closer you are to 10 or closer you are to 20, the harder you're working. Reducing short or having short rest intervals may increase testosterone, lactate, as well as growth hormone concentrations, which may directly affect the influence of hypertrophy of skeletal muscle. Now, it's important to note that women do not have high levels of testosterone at natural levels. Therefore, women cannot bulk up or increase in muscle size like men do. That is a myth, and it is not possible unless women are taking testosterone specifically. Lastly, we reduce performance during subsequent sets if you don't fully recover. So how long should rest intervals be based on the goals? As a reminder, we have 4 goals and we have 7 critical variables. So those 4 goals: power, strength, hypertrophy, and endurance. Power and strength can vary roughly between that 2 to 6 minute marker in between each set for optimal recovery for the next set. We want to have optimal recovery so that we can have as much energy, as much ATP, and maximize our performance for every single set. Hypertrophy, we have again a higher volume load, but with hypertrophy the goal is to have those shorter rest intervals. Going back to that third bullet point above, increased testosterone, lactate, and growth hormone concentrations, the goal of hypertrophy is to increase all 3 of those and have stress upon the muscle. So we're going to have a reduced rest period of 30 to 90 seconds between rest. And then muscular endurance. Muscular endurance, which we'll see in a little bit, we have a really high volume with lower intensity, so you don't need as much rest, so it's going to be less than 30 seconds. So novice, meaning new, intermediate, and advanced strength lifters, it's recommended that rest periods last between 2 to 5 minutes for strength training. These recommendations can be applied to across the board for all goals. It'll depend on the lifter themselves, their current training status, as well as medical status. So this might be an individual ability to determine what is needed for that athlete or client. Here is just an example training for frequency and workout structure. Repetition velocity. Lifting velocity affects the neural, the hypertrophic, and metabolic responses to training. It is highly dependent on loading, which is our intensity, as well as fatigue. So force equals mass times acceleration. Significant reductions in force production are seen when the intent is to perform the repetition slowly. Slow velocity, we have unintentional versus intentional. Unintentional simply means slow velocities are used during high intensity repetitions in which either the loading or fatigue level are responsible for the velocity. Intentional slow velocity are used when sub-max weights, where the athlete has direct control of that velocity. So compared to slow, moderate, and fast velocities have been shown to be more effective for increasing power. Because power, we want to be explosive, fast. Think of sprints, being quick off the line. The goal is to be explosive, fast. So moderate to high velocities are the most effective for enhancing muscular performance. If you want to be fast, if you want to be powerful, you must train that way. There is no shortcut. The critical SAID principle, specific adaptation to impose demands. The SAID principle is one of the most important basic concepts in sports science. It's an acronym, again, which stands for specific adaptation to impose demands, which means the body is placed under some form of stress to allow it to make adaptations for the body to get better at withstanding specific form of stress in the future. The adaptation process does not occur by any one mechanism, yet it is a general tendency of the body which is played out in a number of mechanisms. So again, if you want to become stronger, you must train for strength. If you want to increase muscle size, you must train in the goal phased for hypertrophy. If you want to sprint faster, jump higher, you must add a power component. You have to be specific in the critical variables for a specific adaptation to take place. Again, your 4 goals: power, explosive, includes force and velocity. So force times velocity equals our power. Strength, hypertrophy, which is our increase in muscle size, and muscular endurance. Muscular strength, dependent on the nervous system's ability to recruit motor units and the contractile capabilities of the muscle fibers. So simply, it's the ability of the neuromuscular system to generate force. Loading is going to be dependent on the initial training status. So it's going to differ. The ability to actually load a bar or lift weight will be different between someone who is new or experienced. So how much volume? And then we have a chart for that collectively displays the volume and intensity for every goal and critical variable at the end of the PowerPoint. But you're using 2 to 5 sets. Rest intervals, again, dependent on the exercise, but roughly 2 to 3 minutes. And velocity, for strength, it's going to be slow and controlled. Think of a squat. Squats are typically slow and controlled movements. Muscular power. The increase by performing greater work in the same amount of time, or by performing the same work in less time, again, is to be quick. You want to be as explosive and quick as possible. So what do they include? How do we improve power? We improve it by increasing the rate of force development, how quickly we can develop force or produce force. First, we have to look at the muscular strength at slow as well as fast contractions. It must include the stretch shortening cycle and coordinated movement patterns. So exercise selection is really key here. Multiple joint, ballistic, jumping, explosive exercises that minimize the negative acceleration known as deceleration. Loading. We have integrated of light load and high load, which we'll have a figure on the next slide to further discuss. And then maximal acceleration of concentric muscle actions. On the previous slide, we said integration of low and high velocities. This is known as your force velocity curve. So in the first picture on the left-hand side, you have a purple line and a blue line. Before training, you have force and velocity, but the curve moves. It moves upward, where we're increasing our force production, so we're able to produce more force, therefore we are stronger. On the left side, it's also moving to the left, so it's moving upward and to the left. It's moving upward and to the right. Therefore, your velocity curve from purple to green or purple to blue went from up and to the right, which means you are stronger and you had the ability to move faster. That is your goal. Your ultimate goal as a strength and conditioning coach is to move this curve up and to the right for your athletes. We want to increase their strength and also increase the ability to produce that strength rapidly. The figure on the right shows you maximal strength all the way down to speed. You have to train at low velocity, which is maximal strength, 1 RM repetition max, all the way down that line until you reach speed, which is essentially zero loading and sprinting as quickly as you can. So you need to be able to train at every marker: maximal strength, strength, speed, speed, strength, speed, in order to enhance power. You must note that in order to be powerful, you must be strong first. Muscular hypertrophy is the result from accumulation of proteins via the increased rate of synthesis, decreased degradation, or both. So hypertrophy heavily relies on the protein intake that we take. But furthermore, again, for this class, the loading and volume is key, jumping down to that third and fourth bullet point. So the loading and volume, as well as the exercise selection, if you want to increase in muscle size, you need to incorporate multi-joint exercises as well as single joint with heavy loads, high volume, and short rest periods, because you want to maintain the stress upon the muscle. So therefore you are inducing fatigue and working through that fatigue with proper form, which results in the adaptation of increased muscle hypertrophy, increase in muscle size. Muscular endurance, we're not talking about running outside for miles and miles. Muscular endurance is still in the weight room. We're discussing the ability for our skeletal muscle to work for a longer duration with less fatigue. Again, multiple joints, but large muscle groups. We're going with lighter loads, meaning intensity is light. However, inverse relationship, when intensity is light, volume is high. So we can have repetitions of 12 to 15 per set. Since we have lower intensities, the rest interval does not have to be long, and we can have less than 30 seconds for high repetition sets. The final critical variable in our 7 variables, progression, defined as the act of moving forward or advancing towards a specific goal. It is impossible to move at the same rate over the course of a long-term resistance training, meaning you will not have a linear incline of performance improvements over time. It'll be more like a roller coaster. Improvements will be up and down throughout your entire program. But as long as you're seeing that progression over time, because of the proper manipulation of the acute program variables, FIVR, frequency, intensity, volume, and rest, can limit the training plateaus. So ultimately, at the end of your program, you have enabled a higher level of muscular fitness. So how do we achieve this? Yes, by manipulating those FIVR variables, but also these 3 general principles: program overload, or progressive overload, variation, and specificity. Gradual increase of stress is known as progressive overload. We want to continuously add new loads or new stress to the muscle to essentially, quote unquote, confuse the muscle. After a heavy day or a new exercise or new volume, what happens to the muscle? You become sore. This is where we're applying that overload stress. So it can be induced by increasing the load, increasing volume, altering repetition speed, or even the rest periods. When you have soreness, that is the recovery period for your body because of the stress that you have placed on the muscle. Can you work through soreness? Should you work out when you're sore? There's no literature out there that states that you should not work out when you're sore. Therefore, you have the green light to work out. The more you work out doing the same movements, the easier that movement gets. Over time, you will then need to manipulate one of these 4 things to become sore again, create a new adaptation, and continue the cycle over and over. Variation. It's planned alteration of the acute program variables over time. Systematically varying volume and intensity is most effective for long-term progression. To enhance the long-term gains in performance, it's imperative to plan systematic changes in exercise choice, intensity, volume, and rest. For instance, if you do squats, how can you change the exercise of a squat to different ones to focus on the same type of movement? So variations of a squat can be a back squat, front squat, sumo squat, a deadlift, single leg, pistol squat, lunges, lateral lunges. There are a number of variations for each exercise that we can include within our program to make sure we have proper variation throughout the long-term design. Specificity refers back to our needs analysis. It should look very familiar. We need to be specific to the needs of the sport and the athlete. The muscle actions utilized, speed of movement, range of motion, muscle groups or movements trained. Remember, we want to train movement, not muscle, unless it's a specific need for that individual, for instance, after an injury. 5, the energy systems. Which energy system are we utilizing in the sport, in the athlete, or even our client? What energy system do they need to use most to be able to maximize their efficiency throughout their day, their daily active living? And lastly, intensity and volume of training. We need to be specific to the needs of the needs analysis. Remember, 6, intensity and volume are inversely related. Intensity goes up, volume goes down, and vice versa. It is simply impossible to perform 15 repetitions with 100% 1RM. So again, going back to that example of, if I can lift one time 100 pounds, can I do 100 pounds 15 times? No, it's not possible. Therefore, intensity and volume are inversely related. Key points in prescribing resistance training to improve athletic performance. This slide and the following slide are the design prescriptions for your critical variables of the intensity, again loading, volume, our rest, as well as our repetition velocity, although it's not a specific variable. Our repetition velocity goes hand in hand with the rest of them. So take a moment to review strength, power, hypertrophy, endurance. For those that are new at lifting, as well as experienced at lifting, the different percentages of intensity, how much rest, how much volume should be appropriately applied. Now this table, along with the 4x4 design on the next slide, are recommendations. These are not hard limits, meaning you may see repetitions that say you only need to do it one time. If you did something one time, once a week, are you going to improve? Not a whole lot, if any. So take it with a rule of thumb. This is something that is supposed to be manipulated over time and combined together. If your goal is to be strong, but also have strength over a long period of time, you can combine multiple goals together. So therefore you can combine strength and endurance together. As a reminder, endurance is not, again, in this chapter we're not discussing running long term outside. This is still in the weight room. We can combine strength, power, hypertrophy, endurance all within a training session. It is possible. So take a moment, review this table, look at the 4x4 design, which I think is a little bit easier to break down and visualize, but again, take it with a grain of salt. And these are how to appropriately apply intensity, our volume, our rest, our frequency for each goal.